So basically we represent a signal as x of t, right? Continuous time signal. So in this x of t, x is a dependent variable and t is the independent variable. Okay, so operations performed on independent variable are with respect to x-axis. Okay, so we have a signal x of t and y-axis.
Ma'am, ma'am, this is new unit.
No, same unit, continuation, unit 1. It's unit 1 only.
Okay, ma'am.
Okay. So we represent x of t, continuous time signal in the form of x of t, right? So we can do operations on a signal depending upon dependent variable and independent variable. Okay. So operations performed on independent variable are with respect to x-axis. Okay. And operations performed on dependent variable are with respect to y-axis. Okay. So we shall see what are those operations. So operations based on the independent variable are so we have operations based on independent variable. They are nothing but shifting, scaling, and time reversal. Okay, we can call it as time shifting, time scaling, and time reversal. Time reversal is also called as reflection. Okay, so these operations can be performed on independent variable. So they are time shifting, time scaling, time reversal, or reflection. So operations based on dependent variable are two types. Okay, so they are amplitude shifting and amplitude scaling. Amplitude shifting, amplitude scaling. Also addition and multiplication will come under this only. Addition and multiplication. So today's topic is operation on independent variable. Okay. So we shall see what all operations can be done on the independent variable, that is time reflection or just reflection, shifting and scaling. Okay. So we shall discuss one by one each of these. So we have seen elementary signals, right? So what are the elementary signals? Unit step, unit ramp, impulse, and many other signals, right? So you'll be doing operations on signals for elementary signals. Okay. So firstly, we shall see what are all the shifting, scaling, and time reversal. So first, I'll explain you basically like what I explained you in last semester when we discussed about operations of signals. Then we shall go to problems. Fine. So we shall see time shifting. So what is time shifting? In case of time shifting, we add a constant k to t time. Okay. So if x of t is my original signal, I'll time shift by x of t plus k. Okay. So k is greater than 0. Okay. And k might be positive or negative. So if x of t is my signal, so this is some signal which is existing from 0 to 2 and with amplitude 2. So I time shift by 2. So what happens? You have x of t plus 2. So if we add 2 to x of t, that is 2 to t, the signal occurs 2 seconds earlier. Okay. So whatever signal is at 2 will come to 0. Whatever signal is at 0 will come to minus 2. So your signal will exist from minus 2 to 0 with an amplitude 2. Got it, everyone? So if we add positive integer to this time axis, then the signal will occur 2 seconds earlier, or number of seconds, it depends on k, okay? It occurs that many seconds earlier, or it's called left shifting. Clear, guys? Are you following?
Ma'am, what's the
Can you
difference
give
between the
another
graph on the
example,
left and
ma'am?
the right? Can you tell again?
So you have a signal x of t. Okay. So I'm adding k to t, time axis. So we are dealing with operation on independent variable, right? Independent variable is t. You have original signal x of t. I add k to t. So what is happening if x of t is my original signal? I'm time shifting it. So what's happening here? The signal is occurring 2 seconds earlier. The signal at time t is equal to 2 is moving forward by 2 seconds. Clear? And the signal at 0 is going to -2. Following? This is the case of left shifting or time advance. Time advancement. So so the signal which it will occur earlier or late, it depends on this k value. Okay, this k can be positive or negative. If k is positive, that is a case of left shifting. The signal occurs 2 seconds earlier. So we shall see if k is negative, what happens. Okay. So case 2 in shifting, case 2, k is less than 0 or k is negative. In first case, k was positive. Okay, k is greater than 0, k is positive. So here I have a signal x of t. So it exists from -2 to +2 with an amplitude 3. So I time shift it with k is equal to -2. Okay. So what happens?
Signal starts from 0 to 4, ma'am.
Yeah, the signal will be right shifted. That means if the k is negative, the signal occurs 2 seconds late, or it is delayed by 2 seconds. Fine. So if x of t is your original signal, you time shift it by k is equal to -2. So it will be x of t minus 2. Okay, so what does that mean? The signal occurs 2 seconds late, or it is a case of right shifting or time delay. Okay, suppose you have a signal x of t, original signal. So this is x of t. So if I add -2 to this t, so it's x of t minus 2. So your signal will be present, whatever which is at -2 will come to 0, and which is at 0 will come to 2. Okay, and which is at 2 will come to 4. So this is the signal after time shifting. Are you guys following?
Yes, ma'am.
Following or not?
Yes, ma'am.
So what did you understand from this? If you add a constant k to time, then we get a signal earlier. Okay, when we subtract the constant k from t, you get a signal delayed. Okay. So in case of time shift,
Ma'am, basically the whole thing gets shifted, right? Like,
where?
ma'am, in the first case where we add k is equal to 2,
Yeah.
if the signal from 0 gets shifted to -2 and the signal from 2 gets shifted to 0, right?
Yeah. 2 seconds. You shifted to 2 seconds.
2
At least
second earlier or delayed? Earlier.
Earlier. Which is at 0 will come to -2, which is at 2 will come to 0. Clear?
Yes, sir.
Here also, you can take the same example. I have taken different example. Suppose you have a signal x of t, which is existing from 2 to 2, 0 to 2 with an amplitude 2, x of t. So I have k is equal to negative minus 2. So what happens to your signal x of t minus 2? The signal which is at 0 will occur at 2, okay, which is at 2 will move to 4. So your signal will be present from 2 to 4 with an amplitude 2. Got it? Clear? Is it clear?
Yes, ma'am.
In case of time shifting, what is happening? The waveform remains the same, but the signal is shifted to right side or left side depending on the constant k. Okay, if k is positive, then the signal will be shifted to the left, or it is a case of left shifting. If the constant is negative, there will be right shifting or time delay. The signal will occur late depending on k, time instant k. Clear? So this is about time shifting. So I'll show you one more example. Like I'll make it clear. So your x of t is the original signal. Okay, I'll take an example. Same example, it's occurring from 0 to 2 with amplitude 1. So I want to shift it with k is equal to minus 1. So what will be my signal? It will be x of t minus 1, right? So if k is minus 1, the signal will become x of t minus 1. So our y of t, which is the resultant signal, is equal to x of t minus 1. Okay. So you be giving values to this y of t. Okay. So y of 0 is equal to x of 0 minus 1, which is equal to x of minus 1. So what the amplitude you have at x of minus 1 will go to y of 0. Okay, suppose you want the instant at 1. Okay, so it will be x of 1 minus 1, it will be x of 0. So the amplitude at 1 would be what is the amplitude at 0th instant in x of t. Okay, similarly y of 2 will be at time 2 seconds, it will be x of 2 minus 1. It is x of 1. Y of 2 is equal to x of 1. So what amplitude is present at 1 in x of t will be present at y of 2. Clear? So next we have y of 3, which is equal to x of 3 minus 1, which is nothing but x of 2, right? So at instant 3 in y of t, the amplitude would be the same, which is at x of 2. Okay, that it will be 1. So what about y of 4? It will be x of 3. We don't have any signal at instant 3 in x of t, so no need to worry about this. Okay, so and we'll take y of minus 1. So at minus 1, so it will be x of minus 2, right? But we don't have any signal at x of minus 2, so we'll ignore these two iterations. So you don't have any signal at 3, right? So you can stop your iterations at y of 4. Okay. So now try to draw this. So at y of 0, at y of 0, so it is equal to x of minus 1. So what is the amplitude at x of minus 1?
Ma'am, it's not there.
It's not there, 0, right? So at y of 0, it will be 0 only. Okay, here it will be 0. Fine. Then go to y of 1. At y of 1, the amplitude is same as x of 0. So in x of t at t is equal to 0, what is the amplitude? It's 1, right? So at y of 1, you'll have amplitude of 1. Clear? And at t is equal to 2 in y of t, what is the amplitude equal to? It is equal to the instant at x of 1. At t is equal to 1 seconds in x of t, you have amplitude 1. So the amplitude will be 1. Next, at y of 3, at t at instant at t is equal to 3 seconds. So what is the instant you have at x of 2? You have 1, right? It's coming, it's 0, it's coming down. So it will be something like this. Okay, at y of 4, you can see at t is equal to 4 seconds in y of t, it is equal to x of 3. You don't have any signal at x of 3, so that would be the signal. Got it? You can, if you didn't follow, you can take values like this and take iterations, or you can do directly. If k is -1, right shift by 1 instant. Okay, if k is +1, left shift by 1 instant. Clear, everyone? Shifting, time shifting, is it clear? So this waveform has shifted right by 1 instant. Is it clear? That's what I have told you here. So if it's negative, it will shift to the right, which is at -2 will come to 0, which is at 0 will come to 2, which is at 2 will go to 4. Okay, you have to right shift at 2 times. Okay, if you have negative k value. Here we have negative k, that is -1. So we have shifted by 1 instant. We have the whole signal, we are shifting it by 1 instant. Clear, everyone? Shifting.
Yes, ma'am.
Suppose you have x of t 0 to 3, I'll take with an amplitude 1. How do you plot x of t plus 3? How do you plot this?
Ma'am, from
Start
-3 to
from
0.
-3, ma'am.
From -3 to
0.
0. It is, if k is positive, it is left shift. Okay. So your signal will be present from -3 to 0 with an amplitude 1. Amplitude will not change here, just the signal will be moving right or left depending on the k value, because it is operational independent variable, operations on time axis. Okay. So next I'll give you x of t minus 6. This is your x of t. With respect to that, tell me how will the signal, where will the signal start in t minus 6, x of t minus 6.
-6 to 0, ma'am.
No, here k is negative, right?
Ma'am, 0 to +6.
T minus 6.
Ma'am, with respect to
Ma'am,
x of
3
t,
to
ma'am.
9.
With respect to this signal, this is your x of t. Okay. What is x of t minus 1?
Ma'am, then 6 to 9, ma'am.
Yes. The signal will start from 6 and it will stop at 9. Correct. So if it is x of t minus 1, the signal will start at 1. It will stop at 4. Correct.
Yes, ma'am.
Clear, everyone? So x of t plus 5, from where it will start?
Ma'am, from -5 to -8, ma'am.
From -5 to?
-2, ma'am.
-5 to -2. Correct?
Yes, ma'am.
Yes or no?
Ma'am, we'll be doing like proper questions on this, right?
Yeah, these are just an examples, but you have yeah, you'll have problems on these only. This is just shifting. You'll have scaling also, time scaling also. So if shifting is clear, we'll go to scaling. Is this clear?
Yes, ma'am.
So what did you understand? Did you follow, everyone? So if you have negative sign, there will be right shift. If you have positive sign, there will be left shift. Clear, everyone?
Yes, ma'am.
So what did we understand from this? So if I have a waveform x of t, if I shift it by x of t minus 1, then my waveform will shift by plus 1, right? If I have x of t from 0 to 2 with an instance 1, x of t minus 1 would be from 1 to
3, ma'am.
3, correct? With an amplitude 1. So what is happening? It is shifting, right? By 1 instant. Suppose I have x of t plus 1. I have my original signal x of t and this is an instant from 0 to 2. So what is x of t plus 1?
-1 to 1, ma'am.
Minus 1 to?
1.
Yes. So it's occurring 1 second earlier, correct? So it will be -1 to plus 1. So if you have k positive, your waveform will be shifting left by 1 instant. Clear?
Yes, ma'am.
Are you following? I'm going slow because you have to understand. Clear, everyone?
Yes, ma'am.
So if you have x of t, I can take, if I have x of t plus m or t plus k will take because I taught you k, right? So if you have t plus k, the waveform will be shifted left by k, right? So the waveform will be shifted left by k instants. Yes or no? Will you agree?
Yes, ma'am.
So if I have an original signal x of t, my time shift signal will be x of t minus k. Then the waveform will be shifted right by k instants. Okay. So the waveform will be shifted right by k instants. Got it? Shifting clear, everyone? Left shift and right shift. If you have a k positive value, then it is left shift. The signal will occur that many seconds earlier, k seconds earlier. Okay. If you have minus k or negative value of k, the signal will have time delay. It occurs k instance of time late. Clear? K number of seconds, it will occur late. Clear, everyone? So here we are getting the signal early in case of left shifting. In case of right shifting, we are getting the signal delayed or late. Got it, everyone?
Yes, ma'am.
So now we shall see what is time reflection or folding. Okay. So shifting is clear, right? If you add t plus k, then the waveform will be shifted to the left. If you add t minus k, if you subtract t from k, then you will have right shifting. Okay. Sorry, k from t, you will have right shifting. Clear, everyone? So we shall see about reflection or time reflection. So if I have a signal x of t, the reflection of that will be x of minus t. Okay. I'll draw a signal 0 to 1 with an amplitude 1, and I also have a signal from 0 to -1 with amplitude -1. This is my x of t. So what is reflection of this? X of minus t. I'm multiplying time instant with negative sign. Okay. in time reflection. So how will x of minus t look?
Ma'am, from -1 to 0, amplitude will be 1, and 0 to 1, amplitude will be -1.
Yeah, so from -1 to 0, the amplitude will be 1, whereas from 0 to 1, the amplitude will be -1. Just we are folding the signal about y-axis or vertical axis. This is called time reflection. Okay, so we can take y of t is equal to x of minus t. So give values for t in y of t. This is your resultant signal y of t, which is equal to x of minus t. Okay, so y of 0 would be x of 0. Okay, y of 1 would be x of minus 1. Okay, at instant 1. So this is y of t. So at instant t is equal to 1, you'll have the amplitude which is at -1. Okay, so at -1 we have -1. Okay, so at y of 1 you'll have amplitude -1. Similarly, y of 2 will be x of -2. So we don't need this iteration because you have a signal from -1 to +1 x of t. So we are not worried about instant y of 2, it will be 0. At this instant it will be 0 only, fine. So now we'll go to negative side. Y of -1 would be x of -1 which will be +1. So at instant -1 in y of t, so you will have the amplitude value which is at 1, that is 1. So we have got 1 here. So at y of -2, we'll have x of 2. We can stop our iteration till here only because we have a signal from -1 to +1. Okay. In few textbooks, they would have given you iterations and they would have made you follow. But reflection is nothing but it is folding or mirror image about y-axis or vertical axis. Clear, everyone? Is it clear?
Yes, ma'am.
So,
Yes, ma'am.
everyone, it's clear. Reflection.
Yes, ma'am.
It is also
Yes,
called
ma'am.
as time reversal. Time reversal, reflection, or folding. Whatever you have at x of t, you'll get the mirror image of that in x of -t. Okay, you have to understand that. So this is about reflection and shifting. Now we shall see what is scaling. So scaling means you are multiplying time by some value. Okay, you are multiplying time t by some value. Okay, that value, yeah, we shall see that. It might be less than 1 or greater than 1. Okay, so we have time scaling. So if we multiply your time t by some value, you'll have compression or expansion of a signal with respect to time axis. Okay, so we shall see when we have compression and when we have expansion of a signal. So let our original signal be x of t. So I'm time scaling that with an factor alpha. So I get x of alpha times t. Correct? So we shall see what happens. There are two cases. So alpha might be greater than 1 or alpha might be less than 1. Okay. So we shall see if alpha is greater than 1. So what happens? So I have a signal x of t. I'll take the same signal. Okay. Its amplitude is 2 and time instant is also 2. I have taken a signal x of t. So you're scaling it by a factor alpha is equal to 2. So you have x of 2t. So what you have to do is This time axis you have to divide by 2. Okay, if you divide time axis by 2, what do you get? The signal is present from what happens to a signal? You have alpha 2. You have to divide that by 2. So what happens here? The signal will be compressed. Okay, so it will be compressed, so it will be existing from 0 to 1. Got it? Amplitude will be the same. Understand this much? So in scaling, if you have alpha greater than 1, so the signal will be compressed. Okay? Following?
Yes, ma'am.
So we'll take one example. I'll show you with an example by taking iterations for time. Okay. So suppose I have a signal x of t. It is existing from -1 to +1 with an amplitude 1. Okay, I want to scale it by a factor 2. Okay, so my signal will be x of 2t, correct? So we'll equate it to y of t. Y of t is equal to x of 2t. So if my y of t is equal to x of 2t, so y of 0 would be x of 0. Y of 1 will be x of 2. Okay. So, and y of 2 will be equal to x of 4. So we can stop our iteration at this point because we have x of t from -1 to +1 itself. No need to compute for -2 and +2. So we'll go to negative values. So y of -1 would be x of -2 and y of -2 will be x of -4. So we are scaling this, right? So the signal present at 0 will be 0 only. Okay. So what is at 1? At y of 1, it will be 0. But we can take one intermediate value, right? Midway between -1 to 0, you have -0.5 and +0.5. So I'll take that. So y of 0.5 will be, what is y of 0.5? X of
1.
1. And y of -0.5 would be x of -1. So what happens to your signal? So at instant, so I'll take 1 and -1. So at instant y is equal to 1, we have x of 2. So at y of 1, we have instant 2. At 2, it is 0, right? So we also have a unit here because it's continuous time signals. We can take any values between 0 to 1. So we'll take 0.5. So 0.5 is a midway between 0 and 1. We'll take 0.5 and -0.5. So y of 0.5 would be x of 1. So at 0.5, you'll have a signal which is at 1. Okay, so the signal is compressed. Similarly, at y of -0.5, you'll have a signal which is at x of -1. So what I have taught you is basically you can divide it by the scaling factor. So if I divide
Ma'am, basically the x-axis is divided by the scaling factor, right?
Yes. X-axis, time axis is divided by the scaling factor. So if I divide it by 2 and -2 directly, I'll get this. Okay, the signal is present from -0.5 to +0.5. Clear everyone what is scaling? So this is scaling when your alpha is greater than 1. So next case, this is case 1. Next we shall see case 2. What happens if alpha is less than 1? Okay, case 2. So my y of t will be x of t by 2 or x of 0.5t. So scaling factor here is 0.5. Correct? I'm scaling by a factor of half. So what happens to our original signal? I'll take this as original signal, which is present from -1 to +1 with an amplitude 1. This is my x of t. So the resultant signal after scaling would be y of t, which is equal to x of 0.5 t or x of t by 2. So what will you do? So what will you do? You'll divide by the scaling factor, correct? So what do you get? The
Ma'am,
signal
it'll
will be
increase,
present
ma'am.
from.
Will increase.
So the amplitude, so the signal will be
1
present
to
from
2, ma'am. 2, ma'am. 0 to 2.
0 to 2 only.
And 0 to -2.
0 to -2 only. The signal will be present from -2 to +2.
Yeah, minus. Ma'am, I meant from
The
the origin.
amplitude
Each
one.
side from the origin. Each side from the origin, ma'am.
Yes.
0 to 2 and 0 to -2.
Yeah, scaling means you do this work, okay? Whatever you have the scaling factor, divide that with time axis. Okay, or you can do the other way method which I told you. You can take iterations. Y of t is equal to x of 0.5 t you can take. So y of 0 is equal to x of 0. Y of 1 is equal to x of 0.5. So at 1, so whatever you have at 0.5, what is the amplitude at 0.5? X of 0.5. That you will have at y of 1. So what is amplitude at x of 0.5? This is a ramp, right, with a slope 1. So what is amplitude at 0.5? It's half only, right? So at 1, the amplitude will be 0.5. Clear? This is 0.5. So at y of 1, it is equal to x of 0.5. So what is x of amplitude at x of 0.5? It is 0.5. So at y of 1, the amplitude will be 0.5. So what happens at x of 2? Sorry, y of 2. X of 0.5 into 2, it will be x of 1. So at 2, you'll have the value which is at x of 1. It is 0. Clear? Then we'll take y of -1, which is equal to x of -0.5. So what is the value of x of -0.5 here? Here, what's the amplitude at x of -0.5? What is the amplitude?
0.5, ma'am.
It's 0.5. So at y of -1, the amplitude would be 0.5. Okay. Similarly, at y of -2, you will have the value of x of -1. So at -2 instant, you will have the value which you had at x of -1. Clear, everyone? Is it clear?
Yes, ma'am.
So what did you understand from this? These two? Basically, what did you understand from scaling?
Use it to
Ma'am,
compress
basically
the-
it's scaled to a greater or lesser value, ma'am, according to the scaling factor. What do we
Yeah, if you have a function and if you scale it by an integer, here you're scaling it by an integer, right? If you scale it by an integer, you get the compressed version. Okay, if you have a function and if you scale it by a fraction, you'll get an expanded version. Clear? Is it clear, everyone?
Yes, ma'am.
So I'll give you some examples. You tell me what we'll get. So I have x of 2t. Wait, yeah. So this is my x of t. Sorry. I'll give a signal x of t from 0 to 4 with an amplitude 1. So what will be x of 2t? X of t is the original signal and you're scaling it by an integer 2. What happens if you're scaling it by an integer?
Ma'am, it will be from
0
0
to 2. 0 to 2.
0 to
2.
2.
So how do you get 2? We divide it by time axis by 2. So we'll get to have a signal from which was the original signal was from 0 to 4, but the scaled signal will be from 0 to 2 with an amplitude 1. Okay. Now you do x of 0.5t. This is the original signal, which is from 0 to 4. So what will be x of 0.5t?
0 to 8, ma'am.
Yeah, divide this by 0.5. So you have a signal from 0 to 8 with an amplitude 1. Is it clear?
Yes, ma'am.
Got it? So what is the bottom line of this discussion? If we have a signal x of t as the original signal, then if you have x of alpha t, what you get? You have compressed version of x of t, right? Or if you take alpha as greater than 1, value greater than 0, I'll take, no, value greater than 1. Okay. Or if you can also tell if alpha is an integer, you'll get a compressed version of x of t. So if you have x of t by alpha, what happens? Or if alpha is in the form of a fraction, so what do you have? You have expanded version of signal. So we have seen if x of t is our signal, we have seen what is x2t. So the signal was compressed. Okay, the signal compressed. We have scaled that with a value 2. It is an integer. The signal was compressed. Similarly, we have scaled it with a value t by 2 or 0.5. So it was expanded version. Is it clear? So you can take alpha less than 1 also. It might be point values x of 0.5t or something like that. Or also you can take t by 2 like t by alpha. It depends. Clear? Is it clear, everyone?
Yes, ma'am.
So if you have this alpha in the form of fractions, then your signal will be expanded. If you have alpha in the form of integer, then the signal will be compressed version. Clear, everyone? Shall we see one problem on this?
Yes.
Yeah, so I'll just show you, we'll take one example of a signal x of t. This is instance 1 and this is instance 2. The signal is having amplitude 1. So now you plot x of minus 2t plus 3 and x of t by 2 minus 1. So what all are there in this expression? It has more than one operation, right? So what are the operations that need to be performed in this expression? You have shifting, scaling, and time reversal or reflection. Correct? Yes or no?
Yes, ma'am.
Can you tell again?
So this is a signal x of t. So they'll give you a signal given x of t. Plot x of minus 2t plus 3 and x of t by 2 minus 1. So this is these type of problems you'll get on operations of signals. So what does this function x of minus 2t plus 3 have? What all operations are performed on x of t? You have shifting here because you have x of t plus 3, scaling because you have x of 2t, and time reversal because you have minus 2t plus 3. Correct? We have all the operations, right? All the operations on
Yes,
signal.
ma'am.
So which will you do first?
Ma'am, first
Ma'am.
2t we have to do, ma'am.
Is it? No, there is a law of precedence. Okay. So the law of precedence states that first you have to do shifting. Okay. Then you do scaling. And third you do time reflection or time reversal or reflection. You have to follow this rule. Law of precedence. You cannot do scaling first, time reversal first, then your waveform will be wrong. First you do shifting. So first what you will do for a signal x of t? First operation what you will do? If you want x of 2t plus 3, you want x of 2t plus 3 minus 2t plus 3. So first operation what you will do? Shifting. So what is the shifting? X of t plus 3. Second, you do scaling. It is x of 2t plus 3. Then you do time reversal. X of minus 2t plus 3. Clear? Shall we proceed? Followed or not?
Yes, ma'am.
So first we'll do x of t plus 3. So this is our signal x of t. How will x of t plus 3 look? X of t plus 3. So where it will start, where it will end?
3 to 5, ma'am.
X of t plus 3.
Minus 3 to 5, ma'am. Minus 5.
Guys, you are following? From where will your signal start? It will start from, it is 2 units, 0 to 2. The signal is only 2 units. So it's starting
Minus
at
3 to
1.
minus
If it's
1.
x of
From
t
0
plus
to minus 5. Sorry, 0 to minus 3.
And minus 3 to minus 1.
it is minus 3 to minus 1, correct? See what you are doing, minus 1, minus 2, minus 3, minus 4. So what you are doing basically, I have told we are shifting it with positive. K is equal to 3 here, positive value. So if K is positive, there will be left shifting by 3 instants. So what the signal which you have at 0 will go to minus 3, correct? Yes or no?
Yes, ma'am.
The signal which is at 1 will go to
Minus 2.
minus 2. The signal which is at 2 will go to
Minus 1.
minus 1. Clear everyone? With an amplitude 1. Is it clear? See what we are doing is we are shifting the signal left or right. It depends on K. K value is positive. So you are shifting the signal left. That means the signal is occurring 3 seconds or 3 instants earlier. Correct? Yes or no? Which is at 0 will go to minus 3, which is at 1 will go to minus 2, which is at 2 will go to minus 1. Got it, guys?
Yes, ma'am.
Followed everyone? You're still confused? So we have plotted x of t plus 3. Okay. So next we'll do scaling. X of 2t plus 3 will do. Okay. So how this is our x of t plus 3. So how will x of 2t plus 3 look? X of 2t plus 3. How will this look? you're compressing, you're scaling. This is scaling, right? If you have an factor multiplied
minus 1.5 to minus 0.5.
correct. So we are scaling by a factor 2, so divide by 2. Okay, so the signal will exist from minus 1.5 to minus 0.5. Clear everyone? Minus 1.5 to 0.5. Got it? Yes or no?
Yes, ma'am.
So now we have done x of t plus 3. We have done. We have shifted the signal left by 3 instants and we have scaled it by a factor 2. Now we have to time reverse the signal to get x of 2t plus 3. So from where to where the signal will exist, if you time reverse this, so it is x of minus 2t plus 3. So the signal will be present from
0.5 to 1.5, ma'am.
Is it clear, guys? The signal will be present from 0.5 to
1.5.
1.5. Clear? We are just folding the signal about y-axis, reflection at the last. Clear, everyone? Is it clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Followed? So 0.5, 1, 1.5. Just I am folding it about y-axis. This is 0.5, 1, 1.5 with an amplitude 1. Time reversal. Understood? Everyone? They have also told you to plot. See, first they're telling you to plot x of minus 2t plus 3. We have done that, right? First we did shifting. We took x of t plus 3. Next we did scaling, x of 2t plus 3. Then we did time reversal, x of minus 2t plus 3. Okay, you have to go about like this when you come across problems like this. First precedence is given to shifting, then scaling, then time reversal or reflection. Clear? So they have also asked you x of t by 2 minus 1. So first what you will do? First part of the question is done. Second part is x of t by 2 minus 1. So what will you do first? What operation will you do first?
Shifting, ma'am.
Shifting. So what will you how will you shift it? What will be the value?
T minus 1.
X of t minus 1. Next you will do scaling. X of t by 2 minus 1. Okay. So first let us shift it. So our original signal, I'll draw it once again. So it is this is our x of t. So it is present from 0 to 2 with an amplitude 1. This is our x of t. Now you perform shifting. X of t minus 1. Okay. So how will this? What happens to the signal? Here the shifting factor is
Get delayed, ma'am.
k is minus 1. Correct. So what happens to the signal?
Ma'am, will get delayed by 1 instance, so it will be
Yes.
like 1 to 3.
Correct. So it will be present from
1 to 3.
it will be present from 1 to 3 with an amplitude 1. Got it? Is it clear? So k is minus 1. The signal is getting delayed by 1 second or the signal is getting right shifted by 1 instant. Is it clear? Got it, everyone? Understood or not? Are you guys finding it difficult?
No, ma'am.
Yes or no? So we'll practice more problems, you'll be clear. Okay. So we have done shifting, we are done with shifting. Now we have to scale it by a fraction 1 by 2. So what do you have? X of t by 2 minus 1, or you can also write x of 0.5 t minus 1. So what happens now?
Starts from 0.5 to 1.5, ma'am.
And 2 to 6.
2 to 6, ma'am.
2 to 6, right? You divide it by 0.5.
Yes, ma'am.
Divide it by 0.5. So it will be present from where to where?
2
2
to
to
6.
6, ma'am.
2 to
6.
6. Got it? With an amplitude 1.
Ma'am, it should decrease from 5, right?
No, from 4 it will decrease, correct? Why it will
Oh
decrease
yeah,
from 4?
2 into 2, yeah.
By 0.5 you do if you get confused. Okay? With an amplitude 1. Clear? It will decrease from 4. Just a minute, I am feeling it difficult to draw. Got it? It will decrease at 4 with an amplitude 1. Got it? Did you guys follow?
Yes, ma'am.
So this is with respect to continuous time signals. Okay. So I'll give you, we'll solve one more problem. And tomorrow we'll see with respect to discrete time signals. Okay. How do we shifting, scaling and reflection? How do we do that? So take this one. Yeah, I gave you one simple problem. You try this. Okay. X of t. This is a signal which is existing from -1 to +1 with an amplitude 1. So you plot x of -2t plus 6. Okay. And you plot x of t by 2 minus 4. You try this. Okay. So first what you will do? Shifting. So what will that be? X of t plus 6. Then you will do scaling x of 2t plus 6. Then you will do time reversal x of -2t plus 6. Okay. Similar to this. So this would be first shifting x of t minus 4 you will do. Then you will do x of 0.5 t minus 4. Okay. Will you try this?
Yes, ma'am.
You have any doubts still here? Operations on signals? It is very easy topic to score marks. If you understand the concepts well, it's very easy unit 1. And operations on signals is very interesting topic. You have any doubts? You want me to
Ma'am,
repeat
when
any
is
topic?
internals, ma'am?
What?
When is internals, ma'am?
Internals, you have to check the calendar of events. Even I am not sure. You have any doubts, guys? Understood? Vinay followed?
Yes, ma'am.
Yes, you followed?
Yes, ma'am.
Vineet B,
Yes, ma'am.
Maithili,
Yes, ma'am.
Rakshita, you followed?
Yes, ma'am.
Is it clear?
Yes, ma'am.
You guys have any doubts? If you have any doubts on operations of signals, you can clarify it now. Okay? So today is the first class. If you're feeling, if you didn't follow anything or any silly doubt or any simple doubt, you can ask me. Is it clear? You want me to repeat anything now?
No,
Yes, Akshay?
no doubt. No.
Okay, so we'll see more problems. Okay, so we have seen operations of signals based on continuous time signals. Tomorrow we shall see operations of signal based on discrete time signals. Okay, so
Like the questions which they'll ask,
yeah.
they'll ask from the questions like the topics we did last last few classes also, like the simple numericals and all, like the using the discrete time signal and then finding the energy, the power and all.
Yeah, one question will be from energy or power, one from even or odd, periodic, non-periodic. Those are the probable topics of in the question paper. Okay, you'll have even and odd signals. You have to find even component and odd component of a given signal. Okay, and you have to find energy and power of a signal, and you have to find if the signal is periodic or non-periodic, and you have to find the fundamental period. Such type of questions from classification of signals, and from operation on signals, you'll have such questions. They'll give you a waveforms.
Ma'am,
Yes.
ma'am, will they give any kind of theory questions like define
No,
or
no.
this, or will
Don't
it be only
expect
problem based?
only problem based. Don't expect theory questions in signals.
Okay, fine.
Okay, they might ask you what is energy signal and what is a power signal. How to write definition for that in mathematical form only. How to write equations and all for energy and power.
Okay,
Nothing like theory.
I mean,
okay,
elementary signals, what they'll ask, ma'am?
See, we have done operations of signal with respect to x of t. Correct. Suppose if you
Yes,
have
ma'am.
u of t and all, can you do that? Unit step, unit ramp, and impulse. So there will be operations with along with elementary signals also. We shall discuss that. And you have integration and differentiation also. Integration and differentiation with respect to elementary signals. So we have seen if you integrate a impulse signal, you get unit step, right? If you integrate that. Similarly, if you differentiate unit step, you will get impulse signal, correct? So if you integrate a unit step, you get ramp signal, correct? If you integrate, you get ramp signal R of t. Similarly, if you differentiate a ramp signal, you get unit step. So you'll have waveforms and you have to draw waveforms depending on integration and differentiation. Okay? So we'll discuss about all. So
ma'am.
clear?
But will they ask like finding even and odd signals, ma'am?
They'll ask you to find even part of the signal, odd part of the signal. They'll give
Like,
you a signal.
yes, ma'am.
So if you have any signal, suppose this is your signal x of t, or even part of x of t, or odd
Yes,
part of x of t, x o of t. So even part, how will you find x of t plus x of minus t by 2? Correct?
yes,
Odd
ma'am.
part is x of t minus x of minus t by 2. You
By
have
two.
to draw waveforms and find even part and odd part.
Ma'am, will they ask to find frequency and all, ma'am? Like in the initial, you did some problems, right?
Yes, you can expect such problems. Fundamental period.
Okay, but mostly energy and power is the important one, right?
All are important, even and odd, periodic, non-periodic, and
Yes, ma'am.
energy power. In those three topics only you'll have problems. You can check previous question papers.
Yes,
In
ma'am.
unit 1, you'll have classification of signals only on those three topics, then operations on signals.
Okay, ma'am.
Okay. So you have understood operations of signals, shifting, scaling, reversal, clear.
Yes, ma'am.
So if you don't have any doubts, then we can wind up this class. If you want me to repeat any topic, I'll repeat it. Thank you, students.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.